Hello. In today's video tutorial, I'm going to show you how to use the index mapping technique to create a parametric shading system for a walkway, as we can see here. If you want to follow this tutorial, you will need to install the Parametric toolbox first. You can download it using the link in the description of this video. If we look at this model from the outside, you can see that it actually consists of 64 varying frames. Each of these frames is actually an instance of the same family. And if we go to the family file, the family will look something like this. Okay, so now I will show you step by step how to create this family. Let's create a new conceptual mass family. I will name this family unit. The first thing I'm gonna do in this family is to create an index parameter I, which is of type integer, and it is an instant parameter. Next, I will set this vertical reference plane as my work plane, and I will place a reference point somewhere on this work plane. Then I use the Align tool to move this reference point to the point above the family origin. Next, I'll create a dimension line between this reference point and the level 1 reference plane. Then I will select this reference point and I'll type in 2 meters so that it is just 2 meters above the level 1 reference plane. I can then delete this dimension line because I don't need it anymore. Next, I'll pick this reference plane as my work plane, and on there I will create a reference line circle of radius 10 meters. Now I will place 6 reference points on the circle so that they are evenly spaced. To make sure that these points are actually evenly spaced, I will have to type in their position values manually. So I select the first reference point and make sure that its normalized curve parameter property is either set to 0 or 1. For the second reference point, this value should be 0.1666. And for the next one, it should be 0.3333, so on. The next one should be 0.5. The point after that should be 0.666. And finally, the last one should be 0.8666. If you have done everything correctly, you should have 6 reference points that are equally spaced on the circle. Next, I'll use the reference line tool with 3D snapping enabled to create a hexagon. Then, I'll place a reference point at the midpoint of each side of the hexagon. To make everything a bit easier to see, I'll just hide the circle away. Now, the next step will require a bit of carefulness. I will set this reference plane as my work plane, and I will place a reference point right on top of the already existing one. I'll do the same for the remaining 5 midpoints. Okay, now I will select these three reference points and I'll connect their offset property to a parameter called d1. For now, I'll let the value of d1 be 2 meters. Next, I will select these three remaining reference points and I'll connect their offset property to a parameter called d2. And I will let d2 equal to minus d1. And now you should have something similar to what is shown on the screen. Now I'll use the arc by points tool with 3D snapping enabled, and I will create 6 arcs like this. To make things a bit clearer to see, I will select the hexagon and hide it away. Okay, let's zoom into this reference point and pick this reference plane as our new work plane. I'll place a new reference point right here. And I will set its offset property to 150. You should see the reference point move downward by 150 millimeters like this. Next, I will set this vertical reference plane of this reference point as my work plane. And again, I'll place a new reference point right on the existing one. And I'll change its offset property to 1800. I'll do this one more time, but on this reference point. Next, I'll select the reference line tool and turn on 3D snapping and create a rectangle through these 4 points. I can then select the arcs that I created previously along with the rectangle and click on the Create Form button, and I should get something like this. Next, I'll select this reference point right in the middle and connect its offset property to a new parameter called x. And I'll let x equal to I times 2 meters. Okay, we should save our family now. Now I can create a new conceptual mass family, and I will load the unit family into this new family. I'll place an instance of the unit family somewhere around here. Then I can select it and use the index mapping tool to create 64 copies of this instance. To make it easier to visualize the interior space, I'll make a simple ground plan. Now let's go back to the unit family and select the reference point in the middle. I noticed that when I change the rotation angle of this reference point, the whole frame will rotate. Okay, so let's connect this rotation angle to a parameter called alpha. And set alpha equal to I times 2 degrees plus 10 degrees times sine of I times 11 degrees. When we load the unit family back into the main family, we should get something like this. I'm just creating a new camera view here so we can look into the interior space. Okay, now let's go back to the unit family. You will notice that when we adjust the value of D1, the curvature of the arcs will change. In fact, we can even let D1 be negative, which will reverse the direction of curvature. Now, we will let D1 depend on I by using the formula D1 equals to 1800 mm times cosine of I times 13 degrees. You can easily see how the curvature of the arcs vary based on I. We can turn on the shadows to better visualize the shading effect.